When we manage any kind of system, there's a fundamental tension that always seems to pop up: the push for control versus the need for real understanding.
There's this core belief that underlies so many of our attempts to manage systems. The idea is that if you can control a system's output, then you must understand how it works on the inside. Being able to get the result you want time and time again is treated as proof of that understanding.
But here's the problem. That assumption is often flawed. In fact, it can be downright dangerous. The very methods we use to get control can actually build a distorted picture of the system we're trying to manage. This can lead to actions that don't just fail, they can actually make the system more unstable. So here's how we're going to break this down. We'll start with something called the control paradox. Then we'll look at the black box model, that's the controller's view, and contrast it with what's really going on inside a complex system. We'll see how these models collide, leading to a drift into failure, which ultimately reveals a deep systemic mismatch.
So what is this paradox exactly? Well, it's this. The more you try to exert control over a system, the more you can actually obscure the very understanding you need to manage it safely and effectively.
To really get our heads around this paradox, we have to start by looking at the world from the controller's perspective. And that viewpoint is almost always defined by what's known as the black box model. The controller's main goal comes right out of control theory. It's pretty straightforward: to drive a system toward a specific desired state. And the main tool for the job is feedback. You monitor the system's output, and you apply corrective inputs to fix any deviation from where you want it to be.
Now, to do this as efficiently as possible, the controller treats the system as a black box. What's going on inside is seen as either irrelevant, too complicated, or just unknowable. All that really matters are the inputs you can control and the outputs you can measure.
This diagram shows that mental model perfectly. The controller applies an input to the system produces an output. That output is then fed back to the controller, who then adjusts the next input. It's a simple, linear, and predictable feedback loop. Or so it seems.
But what happens when we actually open up that box? Well, the reality of the system is fundamentally different from the controller's simplified model. What you find inside isn't a simple mechanism at all. It's a network of interacting agents. Every single agent is making its own local decisions based on its own set of rules and how it sees the environment, an environment that includes the actions of all the other agents.
This is what's known as a complex adaptive system, or CAS. And in a CAS, the system and its agents are constantly co-evolving. The system sets the rules for the agents, but the agents' interactions are continuously changing the system itself. Behavior isn't programmed from the top down, it emerges from the bottom up.
So right away, you see this massive mismatch. The controller's model is banking on a predictable, static system where the internals don't matter. The reality is a system with emergent behavior, driven by agent interactions, that's in a constant state of coevolution with its environment.
And it's this disconnect, this collision between the model and reality, that is the true origin of systemic failure. The failure doesn't come from a bad controller or a broken system. It comes from the interaction of two completely incompatible ways of operating.
The black box model leads the controller to think in simple, causal terms. If I apply input A, I will get outcome B. This is the entire foundation of its control strategy.
But inside the complex system, that input A doesn't just cause a direct outcome. It actually acts as a disturbance in the environment. The internal agents see this change, and they adapt their own behaviors in response, all based on their own local rules and goals.
So, the collective result of all those tiny individual adaptations is an emergent outcome. Let's call it outcome C. And this outcome was not and really could not be predicted by the controller's simple linear model. The system hasn't broken, it is just adapted.
Now, a single mismatch like this isn't a failure, but when these interactions happen over and over again, the effects accumulate, creating a gradual and often invisible drift toward a large-scale breakdown.
This kicks off a dangerous cycle. First, the controller sees a deviation. It got outcome C instead of B. It sees this as an error, so it applies a stronger corrective input to force the system back in line. But that stronger input is just a bigger disturbance, which triggers even more significant and still unforeseen adaptations from the agents inside. So the deviation doesn't go away, it gets bigger, or it just changes form. Every correction based on the flawed model actually pushes the system further and further away from a stable state.
The failure that eventually happens isn't located in any one component. You can't point to a single broken part. Instead, it's an emergent property of the interaction between the controller's model and the system's reality.
And this is a really crucial point. This kind of failure is not a sudden break. There's no single moment where you can say, aha, that's where it all went wrong.
Instead, it's a slow, gradual drift. The failure literally emerges from the very structure of the relationship between the controller using a simple model and the complex adaptive system it's trying to manage. The controller is acting rationally based on its information, the system's agents are acting rationally based on theirs. The breakdown is in the mismatch between the two.
And what this all reveals, ultimately, is a fundamental trade-off. The pursuit of control values things like efficiency, simple models, and predictability. But true understanding requires us to engage with complex reality, to anticipate adaptation, and to build for resilience. By prioritizing the simple model needed for control, we risk losing the capacity to manage complex reality.
There's a quote from the cybernetician W. Ross Ashby that really brings this all home. The real objects are in fact all black boxes. What he's suggesting is that this mismatch isn't some special case, it's a universal condition. Every time we try to manage our complex world, we are forced to treat parts of it as a black box. The implication is that this gap between our simplified models and the complex reality is an inherent, unavoidable feature of trying to manage any system.